According to canopy cover data for the city of Yarra, Fitzroy and Collingwood have some of the lowest levels of tree coverage. Both suburbs urgently need more green infrastructure, but for this project, we've chosen to focus on Fitzroy.
Why? Because in Australia, where UV exposure is among the highest in the world, school children are especially vulnerable to skin cancer. And Fitzroy is one of Melbourne's most densely populated suburbs and is home to a larger number of children, many of whom walk to and from school daily.
Here is Melbourne's map. This area is Fitzroy. We will use QGIS tools to overlay a layer of tree canopies data which has been collected on government website. The first location selected for analysis is the East-West Childcare Association. Subsequently, we utilize the Valhalla Pedestrian Catchment plugin to generate isochrones. Let's say we're starting at point A. If we go to point B, we only have to walk 20 meters in direct sunlight. On the other hand, if we choose point C, we're exposed to the sun for a full 200 meters. That's a big difference. Same travel time, but a lot more sun. Next, we're looking at Fitzroy Primary School. Using Valhalla again, we set the max travel time to 8 minutes. Just like before, we start at point A and have two options, point B and point C, both 4 minutes away. But the sun exposure is much worse here. From A to B, you're in the sun for 40 meters. From A to C, it's over 300 meters. As we can see, Fitzroy Primary has fewer roads, fewer trees, and less shade. East-West childcare is better connected and cooler, so we'll focus on improving the area around the primary school. At Fitzroy Primary, the baddest condition around it is Johnston Street, which has no tall trees for shade. It's in poor condition and needs more greenery. Firstly, using QGIS and the Quick OSM plugin, we extract footway data for Fitzroy, Victoria. We set the key to highway and the value to footway to isolate pedestrian pathways across the suburb. Then, we create sidewalks by buffering footways using a 1.5-meter radius. Next, we clip sidewalks with tree canopy cover to reveal shaded sidewalk areas. To compare coverage, we merge shaded and unshaded sidewalks, revealing where Fitzroy's footpaths are protected or exposed. From that, we selected two specific locations for deeper analysis. Let's zoom in on our first location, Fitzroy Primary School. Next, we use QGIS Valhalla to map a 4-minute walking route around Fitzroy Primary School. Then, we clipped shaded and unshaded sidewalks within the 4-minute buffer zone. Next, zooming in on our second location, East-West Childcare. Just like before, we used QGIS Valhalla to map a 4-minute walking route around it, and also clipped the shaded and unshaded sidewalks within the 4-minute walking distance. When we compare the two locations, it's pretty clear that within 4-minute walking distance, Fitzroy Primary School has way less shading, so we're focusing on analyzing and improving the tree network around it. To find the 3D model of Fitzroy, go to data.gov.au and search Fitzroy. Click City of Yarra 3D Buildings by Suburb. Download the Fitzroy.3ds file. Here is the 2.5D maps, which only show the height of trees, and 3D maps, which show the tree blocks. The digital model is then made for running the shadow catchment simulation in Grasshopper. When applied the Grasshopper simulation to Fitzroy Primary School, the results indicates that over 60% of the pathways lack shading, as highlighted by the orange lines on the map. And as stated before, Johnston Street stands out as a key area in need of significant improvement. Zooming in, we can see that when walking from Fitzroy Primary School and turning left onto Johnston Street, a child can only walk for 7 minutes before exceeding the recommended maximum of 5 minutes of sun exposure. Using the Grasshopper script we developed, we simulated how increasing tree canopy coverage can extend shaded walking time. With the addition of 10 trees, total walking time increased to 7.9 minutes, with 2.9 minutes under shade. Increasing to 20 trees extend the walk to 9.1 minutes with 4.1 minutes shaded, and at 27 added trees, a child can complete the full 10-minute walk with exactly 5 minutes spent under shade. We also ran the simulation for a child turning right onto Johnston Street. Without any added trees, the child can only walk for 5.7 minutes. When 10 trees are added, the total walk time increased to 9.1 minutes, with 4.1 minutes spent in shade. And by increasing the number to 16 trees, the child is able to complete a full 10-minute walk while remaining within the recommended sun exposure limit. To implement our tree planting strategy, we decided to integrate trees with roadside parking. We introduced green pavement along the curbside, and trees are planted in between every few parking spots to enhance greenery while maintaining functionality.